Every time we switch on a light, watch television, turn up the heat, or drive our cars, we're consuming energy. In the United States, we consume a lot of energy. Most of that energy comes from burning fossil fuels, like the petroleum we burn in our cars. But there are actually many energy sources, and each source has its advantages and disadvantages. When we burn fossil fuels, the concentrated chemical energy in coal, oil, or natural gas is converted into thermal energy. This thermal energy can be used in the home to heat water for a hot shower or heat up a radiator to warm your house. In a power plant, the thermal energy is used to heat water and produce steam. The steam turns a turbine, which rotates magnets in a generator, producing electrical energy. The electric current is transmitted along power lines to our homes, schools, and businesses. The chemical energy stored in coal, oil, and natural gas is very concentrated, so fossil fuels are a great energy source. But it takes millions of years for the Earth to make coal and oil. We're consuming fossil fuels much faster than they can be replenished. And burning fossil fuels adds carbon to our environment, which increases CO2 levels in the atmosphere, contributing to global warming. About 20% of the electricity produced in the United States comes from nuclear power plants. A nuclear power plant generates electricity using the energy released in nuclear fission, or the splitting of atoms like uranium. Energy is used to heat water and produce steam that can be used to generate electricity. Nuclear power produces air pollutants or carbon dioxide, but there are other environmental risks, including the possibility that harmful radiation can be released into the atmosphere from the power plant or as a result of storing nuclear waste. Electricity produced from the energy of moving water is called hydroelectricity. In hydroelectric dams, water falls through tunnels. The rushing water spins a turbine that rotates a generator, producing electricity. The rise and fall of the tides and waves can also be used to drive turbines. While moving water is a cheap, clean energy source, damming a river or interfering with the tides can upset the natural ecosystem. And dams and the reservoirs behind them take up a lot of space that could be used for other purposes. Another non-polluting energy source is wind power. The wind blows the propeller blades of windmills. This turns a generator producing electricity. But only a few places on the Earth are windy enough to rely on wind farms for energy needs. And wind farms disrupt the landscape and the migratory patterns of some birds. In areas where magma is relatively close to the surface of the Earth, geothermal power plants can tap into the underground thermal energy to generate steam to rotate turbines and make electricity. And then there is the incredible energy of the sun. The sun's radiant energy can be used to heat homes or provide hot water. And energy from the sun can be collected and converted directly into electricity using photovoltaic cells. But sunshine doesn't always reach the Earth because of the day-night cycle and cloud cover. So solar energy must be stored or combined with other energy sources. There are also alternative energy sources, like hydrogen. The hydrogen stored in this fuel cell has been extracted from water using electric current. When the hydrogen is recombined with oxygen, electricity is produced to power the car. And the waste product is water. The challenge is to find a cheap, clean way to extract hydrogen and a reliable way to store and transport it. A hybrid car has a combustion engine and an electric motor. The energy source for both is gasoline. The gasoline can be used to power the engine, or it can be stored as chemical energy in the car's large batteries. The batteries power the car's electric motor. Hybrid cars are more energy efficient, but not pollution-free. Another alternative energy source is biomass, or the burning of renewable organic matter like wood or sugarcane fibers, to make steam, spin turbines, and produce electricity. Burning organic matter for energy is one of the oldest uses of natural resources. But it would take an enormous amount of land to grow the materials needed to meet today's energy needs. A future energy source might be nuclear fusion, which would use the energy released when small atoms are combined into larger atoms to produce steam, drive turbines, and generate electricity. The challenge for this technology is for scientists and engineers to develop a way to contain these very high energy nuclei long enough for them to collide and fuse. There is no easy solution to meeting our ever-increasing energy demands. Reducing consumption is a start. Developing a long-term strategy that considers the environmental and economic pros and cons of our energy options is a must. What's your choice?